Hello, y'all. My name is Andres Barrera. I'd like to welcome you to the program of the Environment's 2020 Capstone Symposium. Today I will present to you my poster, A Dig to Identify the Cause of Death of Sword Ferns at Seward Park. A little bit of background. Forest understories are an integral part of the forest ecosystem. They provide habitats for other organisms, they prevent soil erosion, and provide us with a beautiful place for recreation. In 2013, though, sword ferns were reported to be mysteriously dying throughout Seward Park in the Pacific Northwest with no cause. Therefore, there is a need to understand the physical and biological links associated with the die-off. On figure one, I have a map of Seward Park with its trails. As I said, there's a lot of recreation that happens at Seward Park, such as biking, rollerblading, boating, hiking, um, barbecuing, uh, and it's one of our last old growth forests in the Seattle um, area. Figure two shows a healthy area of Seward Park, a healthy sword ferns from Seward Park. As you can see, it's very lush, very green, it's beautiful. On figure three, there is a area of Seward Park that has unhealthy ferns, which have died off and cleared completely out. So I wanted to ask, is there a relationship between soil properties and the sword fern die-off at Seward Park? In order to do this, I partnered with Friends of Seward Park and Haven Ecology and Research. I learned a lot. I learned research protocols, how to set up a sample plot, how to collect the data, and how to process it. Once it was processed, I learned how to enter the data to make it available for others. So in order to answer my question, I took two types of um, samples. I took bulk density samples and soil texture samples. So for my bulk density sample, which I have a picture of on figure four, I sampled from the third layer of soil, which is known as the B horizon. So we have the O horizon, which is the organic matter, the A horizon, which is, and then the B horizon. I used a copper core shown on the picture, which is an exact volume of 2.73 grams per centimeters cube for the soil sample. I then took that home and I measured the mass of the soil. Uh, Once I had the mass of the soil, I dried the soil completely in the oven and weighed it again. That would give me the bulk density. For the soil texture sample, I also took the samples from the B horizon from 5 different locations from the plot that we set up. It was usually every corner and then the middle. Once I took that home, I separated the sand particles and the silt particles from the sample by wet sealing them. I then took measurements of, I had first taken measurements of the total mass of the sample and then measured the, the individual texture masses. So as for my results, for bulk density, as you can see, the gray is Smith's Reserve Park, which most all ferns are healthy there. And the yellow is the Seward Park healthy ferns areas. And the blue, which is Seward Park symptomatic ferns. On the x-axis, I have the number of dead ferns in each plot. On the y-axis, I have the bulk density of each plot. For my soil texture, I have on the graph I have the blue, which is the sand percentages, the orange, which is the silt percentages, and then the gray, which is the clay percentages. On the x-axis, I have the percent of that type of soil per each plot. So from the summary of my findings, if you take a look at figure 6, the first graph, there's not a strong relationship between bulk density and the sword fern mortality. So bulk density ranges from 0.65 to 1.3 grams per centimeters cube, and there is a mixture of healthy and unhealthy ferns throughout those bulk densities. As far as soil texture on figure 7, the second graph, there is also no significant difference between the soil textures. Both parks on average have a higher amount of sand, and both parks on average have similar amounts of silt. The symptomatic area of Seward Park does do have about a 50-50 amount of silt and sand. But it's not statistically different. So implications, continued research is needed. New data collected with the data that we have collected can uncover other potential causes. Continued monitoring of these new and current die-off sites is necessary to continue to track the impact of the die-off that it's having on Seward Park's understory and understories across the Pacific Northwest. And also finding a solution to the die-off will keep the beauty of the park for us to enjoy and the habitats of many organisms. Figure 8 is just a photo of Seward Park where many people are used for recreational activities. On the picture, you can see a person riding a bike and people walking the trails. I would like to say thank you to both my site supervisors, Tim Billow and Dylan Mendoza, for supporting and guiding me through this research process. It's been great. I've had a lot of fun. I've had to experience things that I've never thought I'd be able to experience before, as well as I'd like to say thank you to my faculty advisor, Gordon Bradley, who took the time to listen, review, and suggest sources for my project. And again, I'd like to say thank you to you all for being here. You guys could be anywhere else, but you guys chose to be here with us. And so I'd like to say thank you again. Hope you guys have a good rest of 2020.